Pen-Based Computing Independent Work Seminar Fall 2016. My name is Ananda Gunawardana. I'll be teaching this seminar. What is this seminar is about? This is an independent work seminar specifically focused on making pen-based computing. So I'm going to show you here. I can mark up a document with pen annotations. So the pen-based computing is not about just annotations, but about recognizing those annotations and thinking through what type of applications are good for pen-based computers. Your grade in this course will be based on your project outcome. You're encouraged to work as part of a team, 2 to 3 students, but project can be modularized to make things independent so you can easily schedule things among yourselves. There's a great deal of attention paid to the usability of your product. It must be simple to use, and it must use a pen and must be designed for pen input. At the end of the semester, you should have a deployable product that can be used by other people. We'll demonstrate some of those products that prior courses have done. So the course will focus on 3 aspects of pen-based computing: creating a usable product using human-computer interaction principles, learning the technical tool set. For example, Visual Studio 2015 and C# would be one of the languages you may use to program pen applications. One of the really interesting things about pen applications is it's not about just strokes. It's about recognizing what objects are made by those strokes. We call that sketch recognition. We will develop algorithms, techniques, and data structures for that. During Thursday meetings, we'll present some of these ideas on how to develop applications, and later students will demonstrate prototypes of the applications. So let's take a look at some of the examples of pen-based applications. Our first application is called the graph simulator. So let's see what this does. The idea is that given a graph, so we have a smart paper, we can draw certain strokes, and this program will identify the strokes and create the corresponding object. In this case, it's a circle. So think about this as a graph with multiple nodes, and then we connect the nodes by drawing the edges. Let's draw the edges here. And essentially what you can imagine now is that inside the computer, it has to create a model of recognition to understand this structure, which is a graph. And it also assigns some default values for the graph edges, like in this case 10. And what we can do is, with the pen computer, we can write, if you want to change it, you can write any number on the top of that to change that number. So this would require the computer to understand what we write and convert this into an actual data point. Now, once this is all done, what we can do is apply one of the graph algorithms to this program. So say, for example, we want to use Dijkstra, so we choose a source, and then we choose a target. And the goal is to find the shortest path from source to the target. So we ask the program to animate this process. Notice that this was a graph drawn by me, and now it animates and looking for the shortest path. This also demonstrates the application of Dijkstra's algorithm. The ones that are in blue are the ones that the shortest distance had been computed, and the ones that are red are the ones where things are on the priority queue. Now in this case, the destination was found, and it gives you the shortest path. So this is one of the applications, and obviously you can expand this to do more if you like. You can add more nodes, you can extend this graph. So the flexibility of pen application is really the ability to change things without having to use any kind of a templated program. So this is one example of what one would do in an independent work seminar.